All right, this is our very last section for Module 3 in Geometry. 3-10, perpendicular and distance. Um, that means that we will be doing our review, and I'll be expecting all of your summaries, so I'll be looking for those. We'll be doing our review tomorrow, which means we will be testing on Thursday. That means the last day I'll take any work from Unit 3 is Thursday. And since the hurricanes, Thursday will be also the last day I take any work, late work, from Unit 1. Remember, with 3-7, we started Unit 2 work in my geometry classes. And so 3-7 through 3-8 through 3-10 will be on quarter 2. But remember, starting in quarter 2, once we test on a module, that'll be the last day I take any work for that module. All right, so we have a couple things you can read up here. We have the perpendicular postulate. We have basically the shortest distance between 2 points is a straight perpendicular line. All right, so these require quite a bit of work. If you want to credit on this assignment, then you're going to show the work as I show you here in class on these notes. Now, I've already made the test. It is a 50-point test. There's a lot of sections. There are 2 questions from this section. Those 2 questions are worth 4 points apiece. That means 8 out of the 50 points are from this lesson. And if you want the 8 points for these problems on the test, you must again show your work. No work, no credit. The answer is only worth 1 point. You get the right answer, great, that's worth 1 point. Well, you're going to be missing 3 points. 3 points is all of the work for all of the steps it takes to get to that answer. Okay, so we've got steps 1, 2, 3, and 4. All right, a lot of steps, including the distance formula. So there's a lot going on here. So you must show your work. All right, not negotiable. So we are going to find the distance from a point to a line on coordinate grid. So we're going to make a perpendicular line here. All right. So starts out, we have a line, line L, and we have 2 points. All right, point 1, point 2, find the distance between L and point P. So the first thing we need to do is we need to find the equation of the line for line L. So in order to do that, you must find your slopes. We have our 2 points. So they use the slope formula, change of y over change of x. They even filled it in for us, okay, because we have our 2 points. So 4 minus 2 is 2. 5 minus 1 is 4. We simplify all of our fractions, so that is 1/2. All right. Now it wants us to write an equation of the line using the point 1, 2, because that's my first point. It's the point furthest to the left, so it's when we come first on that line. So this is my x1, y1. All right, so we know our y, our m, that equals m. We know x, we must find b. So we're going to find our b. So we have got y is 2, m is 1/2 times x, which is 1, plus b. All right, so we used our point, which is the point on the line, the first point on the line, and the slope of the line. So 2 equals 1/2 plus b. I'm going to subtract 1/2 from both sides. B equals, well, you have 2 wholes, subtract 1/2. You want an improper fraction, all right, and so that equals 3/2. All right, when we're dealing with the equation of the line, you want it in fraction format, even if you leave it as an improper fraction. All right, so we have our m equals 1/2. We have our b equals 3/2. And slope-intercept form is y equals mx plus b. All right, so this equation for line L, so line L equation is y equals mx plus b. All right, we have our equation for line L. That is what we were given. I'm going to switch colors because there's a lot of math going on here. All right, so it wants us to find the equation perpendicular to line L. Well, what do we know about the relationship of perpendicular slopes? Well, we know when we have a perpendicular slope, you are going to write the reciprocal of the fraction and do the opposite sign. Okay, so we flip our fraction, that's the reciprocal, and opposite sign. So let me check my slope. Okay, so if my slope starts off as 1/2 to be perpendicular, all right, so we're going to flip it, so that's 2/1, and we're going to do the opposite sign, or it's -2. Okay, so this is my m for the perpendicular line, -2. All right, find the equation. So we found our slope. Now that means we have to find the b. Well, it needs to go through, the perpendicular line needs to go through this point. So this is our point, okay? It's 1, 7. So there's the point on the line. We have our slope. Okay, the point on the line. That's our x, that's our y. This is our m. And we're talking about line W. Okay? So we have got y equals mx plus b. We've got the y, mx. Let's find our b. So find b, because we don't know what b is. Okay? So y is 7 equals m x plus b. So we'll find b. So 7 equals -2 plus b. All right, add 2 to both sides. B equals 9. All right, so this is, we know our m equals -2. We know b equals 9. And our equation for line, helps if I spell it correctly, for line W is this, y equals m x plus b. All right, so we have equation 1, we have equation 2. All right, so we have found the equation for the line given. We've even found the equation for what this perpendicular line is. All right, now our next thing we need to do is we need to find the exact point on this line where we cross it. All right, so in order to do that, we are going to solve the systems of equations. So we're going to find the point that intersects L and W. All right, so we already know this one here. We want to know where W intersects L. Okay, so we have two equations. We have got y equals 1/2 x plus 3/2, and we have y equals -2x plus 9. All right, so we have a systems of equations, which just means we have two equations. Now, you can solve systems of equations 3 different ways. First one is graphing. I don't see a graph here, so we aren't doing that. The second way is by substitution. Both of these equal y, so you can set this equal to that and solve for x. And you could totally do that. But there's like some nasty little fractions up in here, and well, I don't want to do that. because I'm a lazy mathematician. So that leaves elimination. So when I can, I like to use elimination because, hello, you're eliminating something. One, will eliminate all the fractions, and two, will actually be eliminating that x term. So that is your goal with elimination. All right, so let's check it. So what number, because we already have minus 2x, so if we want to eliminate this term here, that means I would need a positive 2x here, because 2x minus 2x is 0, and 0 means we've eliminated it. So what number do I have to multiply this entire fraction by? I mean, not this entire fraction, this entire equation by, in order to get this to 2. Well, let's see. 1/2 of what gives me 2? Well, 1/2 of 4. All right, so we're going to multiply absolutely everything in here by 4. So we're going to multiply it by y, we're going to multiply it by 1/2 x, and we're going to multiply it by positive 3/2. So let's do that. Okay, so that gives me 4y equals, well, 1/2 of 4 is 2x plus 3/2 of 4. Okay, so let's take this one step at a time. So your top number multiplied by here. So 3 times 4 is what? 12. Okay, now let's divide by the bottom number. 12 divided by 2 is 6. Okay, see, just break these down. Multiply the top, divide by the bottom. All right, hey, this looks a little more doable. So when we use elimination, all right, we are going to add our 2 equations, top down. All right, so I have a y plus 4 more y's, that's 5y. All right, we did our job successfully because minus 2x plus 2x, well, we've eliminated it, hence the term. And then 9 plus 6, well, that's 15. But we don't want 5y, we want y, so divide both sides by 5. And you get y equals 3. Now, would you end up with y equals 3 if you had set them equal to each other and did the substitution method? Yes. If you want to, you can try it out, be my guest, or you can trust me. Either way is fine with me. You will not offend me if you're like, yeah, I want to do all that math. Rock on. Go ahead. There's nothing wrong with using the other method. Okay, it's mathematically sound, and if that is the method that you like and you're comfortable with, cool, I'm fine with that. All right, so we found y. Well, our points are x, y, so now we got to find x. All right, so do I want to put that in there? Ooh, no, because we've got fractions, so yeah, can I avoid that? Yes, I can. So we're going to put in this 3 into my red equation. All right, so we're going to do the red equation. We're going to put 3 in here. All right, so 3 equals minus 2x plus 9. Okay, just substitute it in. I'm using that red equation. So let's find x. All right, let's find x. So we'll subtract 9 from both sides. Okay, so minus 2x equals, well, 3 minus 9, that's a minus 6. Divide both sides by negative 2. And I've gotten x equals 3. Ah, cool. All right, x equals 3 as well. So we're going to let this be point Q, and point Q is 3, 3. All right, so we have got point Q. Okay. And so point Q is on this line at 3, 3. Okay, so 1, 2, 3, 1, 2, 3. Okay, so that's point Q. All right. So I found my equation of line L. I found the equation of the perpendicular line. I have found out exactly where that perpendicular line will cross line L, okay, with point Q. So 1, 2, 3. Okay, a lot of work so far. See the work. All right, so the very last step that we do need to do is we are going to use the distance formula, which I know many of you need help with practicing, to find the distance from P to Q. Okay? We need the length of that pink line. All right. So we know P is 1, 7. P is 1, 7. And we just found Q is 3, 3. Okay. P is furthest to the left, so that's going to be 0.1. So that's going to be x1, y1. Okay. Q is furthest to the right, because remember we read left to right. So that's x2, y2. Remember, this is your distance formula, which means it's a formula. We're going to plug into this formula. All right? So we're going to really long radical. Let's fill it in. y2, no, sorry, x2 is 3. Minus x1, which is 1, squared, plus y2 is 3, minus y1 is 7. Okay, squared. All right, so fill it in. Now we're going to do the math inside the parentheses first, okay? Before you do anything else, do the math inside those parentheses. All right, so inside my parentheses is 3 minus 1, which is 2, squared, plus math inside the parentheses. So 3 minus 7 is minus 4, squared. All right, once you math inside your parentheses, and then you square the numbers that are inside the parentheses. So again, still have that really long radical. So 2 squared, 2 times 2 is 4. All right, minus 4 squared, negative 4 times negative 4. Well, negative times negative is a positive, and 4 times 4 is 16. So keep your radical, add up the numbers, so that is the square root of 20. And then you have your handy dandy calculator, and, ooh, glare. All right, so these 20, the square root of, and we are, did it tell us what to round to anywhere? No. So we're going to round to the hundredths place. So that would be 4.47. Or if you round it to the 10th place, that would be 4.5. If you were having to put this in, it would tell you exactly where to round it to. All right? So it took us 1 full step, 2 full steps, 3 full steps, 4 full steps. See all of this work? All of this work is what I expect to see when you do problems like this one. All right? Don't forget your summaries. We do our review tomorrow, so I'm going to be looking for summaries. All right. Let's go on the back. Parallel lines. So are we specifically told that the lines are parallel? Okay. So let's see. You've got a blurb about parallel lines, and then you have another blurb about parallel lines. You can read these theorems and the distance between parallel lines. You can read about those. Let's do the math, okay? Let's do the math. So, how do we know these lines are parallel? Well, if you have parallel lines, you have the exact same slope. Well, minus 3, minus 3. Our slope's minus 3 for both lines. They have to be parallel. That is a given. We proved that with our proofs. So we're going to move on from there. So we know these two lines are parallel, and the first equation is R, second equation is T. So let me see, this is line T, and this is line R. All right. let me do a capital R so you don't think it's liner. So that's line R. Okay, so we're going to solve the systems to find the endpoints of the segments that are perpendicular. Boop, boop. All right, to lines R and T. We know the slope of R and T is -3. So we're going to let line Q be perpendicular to R and T. All right, so I don't have a picture, so every time I don't have a picture of something, I like to draw a picture. So we've got, this is line R. All right, I'm going to do my best to draw a parallel line. We're going to pretend that's parallel. That's line T. And then it says, let Q be perpendicular. Okay, Q. All right, so I draw a picture to represent it. All right, so first up, let's see. I need to write my equation for line Q. All right, so what do I know about my slopes? All right, so if I have a line, it has to be perpendicular, so I know that, well, if my slope here is -3, okay, to be perpendicular to that, I would need to flip the fraction and then do the opposite sign. Well, this is a whole number. To make it a fraction, I put it over 1. So to flip 3 over 1, all right, 1/3, and the opposite of a negative sign is a positive sign, so perpendicular. All right, so we have our perpendicular slope. All right, either way, we are finding a perpendicular slope for the perpendicular line. So the slope of Q is the opposite reciprocal of -3, which is 1/3. We're going to use the y-intercept of line R. Okay, this is being given to us, all right, of 0, -5 as a point through which line Q will pass. All right, so this is being given to us. So we are being given an X and a Y. Okay, we're given the point and a slope. So we can use a different equation. Okay, we're going to get the same answer. We can use point-slope form because we're given a point, we're given a slope, we can find point-slope form. All right, so let's see. So y minus y of 1 equals m, which is our slope, equals m x minus x of 1. All right, let's fill it in. So y minus y of 1. Okay. Remember, this negative sign does not cover, that minus does not cover that negative. All right, and that equals my slope, 1/3 times x minus 0. All right, so a negative times a negative is a positive, so that gives me y plus 5 equals, well, if we distribute, 1/3 x, and anything times 0 is 0, so we can leave that out. Anytime you multiply something times 0, it's 0, and then we can actually not write anything because it's nothing. All right, so we want this in y equals mx plus b. All right, we want this in the slope-intercept form. Okay, point-slope form, slope-intercept form, all of these equations from algebra coming back. So we want this in the y equals mx plus b, so we have got to move the negative, this 5, so subtract 5 from both sides. Now notice I kicked that minus 5 off to the side because 1/3 x minus 5, not like terms, so that's y equals 1/3 x minus 5. All right, so this is line Q. All right. So now we have 3 equations of lines. You have one for line R, line T, and line Q. All right. So let's see which ones they want. So we're going to solve our system's equation. We want line T and line Q. All right, so line T is here. And why do we want line T? Well, it already told us what point it hits with line R right here. So now we are going to, since we already know where it hits R, we now need to find out where it hits T, okay? So that's why we're using line T. So line T, all right, line T is y equals negative 3x plus 6. And then we have line Q, which is y equals 1/3 x minus 5. All right, so again, we have options. All right, there's no graph, so we're not graphing, okay? We could do substitution because they both equal y. So we could set minus 3x plus 6 equal to 1/3 x minus 5, and you could solve for x and then substitute that in. We could do that. If you want to, rock on. Go out with yourself. In class, we decided that we were going to use the elimination method. I do love the elimination method. So that is what we decided to do in both the classes. So let's check it. So if we're trying to remember, our goal is to always eliminate our x term and the fraction. We always want to lose those too. All right, so minus 3x. So in order to eliminate minus 3x, this needs to be a plus 3x. All right, so 1/3 of what number would give me plus 3? All right, so 1/3 of what number would give me plus 3? 9. Okay, 1/3 of 9 is 3. Alright, so we're going to multiply everything in here by 9. Alright, so 9y equals, well, 1/3 of 9 is 3x minus 9 times 5 is 45. Alright, let me rewrite line T down here. So y equals minus 3x plus 6. Alright, so we are adding these up. Oh, here, let me do this one. We're adding these up. Alright, so 9y plus another y, well, that's 10y equals, alright, we successfully eliminated our x. And then minus 45 plus 6, well, it's minus, 39? Yeah, 39. All right, last step, we're going to divide both sides by 10, and y equals a negative 3.9. All right, we found y. All right, now we have to determine if we want it, because we have to find x now, because we've only found y. So we have to decide, all right, do I want to use line T or line Q? Personally, I want to use line T because there's no fractions involved. So, all right, so minus, you could use either, okay? You could totally use this one if you wanted to, okay? You'll end up with the same x. So minus 3.9 equals, all right, minus 3x plus 6. Alrighty. So solve. So minus 6. So minus 3x equals minus 9.9. Divide both sides by negative 3. And x equals, well, negative divided by negative is a positive, 3.3. All right, so we now know where line Q intersects line T, and that would be at point 3.3 comma negative 3.9. Okay, there's our point. All right. So we want to calculate the distance between line R and line T. All right. So this is where we cross line T, okay? And this is where we cross line R. So we already have x1, y1. So that makes this x2, y2, all right? Because line Q, this is the point where it hits line R, and then this is the point where it hits line T, all right? So our distance formula, we're going to find out how long Q is. All right. So we've got x2, which is 3.3, minus my x1, which is 0, whole thing squared, plus my y2 is minus 3.9 minus a negative 5, all right, squared. All right. Remember, this minus sign is not the same as that negative sign. Okay. So remember, we always do the math inside the parentheses first. PEMDAS, parentheses, then exponents. All right. So large radical. So 3.3 minus 0. So that's 3.3 squared plus. All right. Negative times negative is a positive. All right. So for all of my, I don't want a math brain. So a negative 3.9 plus 5 equals 1.1. 1.1 squared. All right. Now that we have math fully inside each of my parentheses, now that we have one number inside each parentheses, now we're going to square those. All right, don't lose the radical. 3.3 squared, which is 3.3 times 3.3, 10.89. 10.89 plus. And then we have 1.1 squared. 1.1 times 1.1 equals plus 1.21. Okay, still not done yet. Square root of. So we're going to add 10.89 to that. That equals 12.1. Okay. And we weren't given anything, so let's see. Square root of that. 3.47. So if we round it to the nearest hundredth, it'd be 3.48. If we round it to the nearest tenth, it'd be 3.5. All depends on what it tells you. Due to the nearest hundredth, why not? So 3.48 or 3.5. All right. So again, lots and lots of work. Need to see lots and lots of work if you want credit for this assignment. Need to see lots and lots of work if you want full credit for these items on the test. All right. Good luck.